Warshall. Okay. Warshall's fluids over. This is Warshall's algorithm. We should have done this earlier. I forgot to keep it in the notes, so I thought something is missing. Then I understood Warshall is missing. So Warshall's algorithm, this is used to find the transitive closure. What do you mean by transitive closure? You all have studied your DMS. Transitive closure? Yes. What's transitive closure? Anybody?
Don't know, ma'am.
Huh? Don't know. If there is a path between AB and BC, we assume that there is a path between AC also, isn't it? That is only transitive closure. So adjacency matrix for a given graph, the transitive closure is nothing but it's defined as an n cross n Boolean matrix in which the element in the ith row and the jth column is 1 if there exists a non-trivial path, that is a directed path of positive length from ith vertex to jth vertex. Otherwise it is 0. Okay. So if we have a graph like this, let me write the adjacency matrix for that. If there is an edge, it is 1. If there is no edge, it is 0. So A, B, C, D, sorry, this way. Next, if someone will ask, do you know this? It is handled in DAA means you'll also say same thing. No, ma'am. As you replied for me now. Do you know transitive closure means? No, it seems. In the same way for DAA also. If some topic is repeated or if you have to recollect something from DAA, you will say no, ma'am. Or no, sir, it was not done. Okay. So given a graph, this is the diagram. So given a diagram, the directed adjacency matrix is if there is a path, it is 1. If there is no path, it is 0. Okay, A to A, 0. Yeah, now A to B. Is there a path between A to B?
Yes, ma'am.
So we will record it as 1. A to C, 0. A to D, 0. B to A, 0. B to C, 0. Sorry, B to B is 0. B to C, 0. B to D, we have a path, right? Now, from C, if you look into this only, you can say from C, you have no outgoing edges. Simply, we can write zeros, isn't it? From C, we cannot reach any other vertex. See, it has only incoming edge, no outgoing edge. Only if you have outgoing edge, you can assume that there is a path from A to some other node. Now, D. D has two outgoing edges. So, D to A, there is a path. D to B, there is no path. D to C, there is a path. And D to D, there is no path. There are no self loops. So, diagonal elements will be 0. Now, we will have to find transitive closure of this. Okay. So, we can generate this transitive closure with the help of DFS or BFS. So, we will traverse starting at the ith vertex and which gives the information about the vertices reachable from it and the columns that contain ones in the ith row of the transitive closure. So doing such traversal for every vertex as a starting point is nothing but your transitive closure. Okay. So it's a method traverses the same diagram several times. Here we traverse the same diagram several times and we set, and that is nothing but your Warshall algorithm, which was discovered by Stephen Warshall. Okay. So if at all, if there is a path between any two vertices, we assume that the diagram's vertex is represented as 1, equal to 1. if there is a directed path of positive length from ith vertex to jth vertex. So every time we will place, as we did in our plots, we place one vertex in between and try to find the transitive closure of the graph. Same method as we had followed in our plots. So this will be too easy for you all now then. So let's start. The adjacent matrix will form your, so we will consider a row of 0 now. Row of 0. Now let's take this. We are finding transitive closure. So we have this. Yeah. How do we get R1 now? Or 1. The thing is, you will have to just write down the first row and first column as it is. That's a procedure, isn't it? So we'll write down 0, 0, 0, 1, 1, 0, 0. Now we will try to find values here. Yes, now you tell me if both are 1s, then it is 1, otherwise it is 0. Here, what is the value here? Same as you did your Floyd's. What's the value you should record here? This, this, and this, like this. If both are 1, it becomes 1. Otherwise, it is 0 only. So it is 0. Here, this. 0.
0.
Yes, here again 0 and 1. So we should retain 1. Isn't it? Now, 1 means existence of path. Now, 0, 1, 0. So both are 1, then only we can replace by 1. Otherwise, no. So we'll retain as it is. 0, 0, 0. For this, it will be 0 only because all zeros. Anything with 0 is 0 only. 0 into 0. 0 into something is 0 only. Now, here, yes, 1, 1 and 0 here. What is the value I should write here now?
1.
1. So I should write down 1, and this is the new entry, whatever we have got highlighted. Now, here 1, 0, already 1. So we will retain that 1. And here again 1, 0, already 0. This is also 1. 1 into 0 is 0 and 0. So it is 0 only. So this is the new entry, whatever we got. Likewise, you do up to R of 4, isn't it? So first now next second row, second column we'll consider, then third row, third column, and then fourth row, fourth column. Will you do it? Because you are all familiar with Floyd's. You understood? It's the same way. The only thing is here you have zeros and ones. There you had values, isn't it? 0, infinity, and values, numerical values you had. Here we'll have zeros and ones. You'll record 1 if both are ones. And if already there is 1, we will retain it as it is. 1 means the existence of the path. 0 means non-existence of the path. Okay. So I want you all to do with R2, R3 and R4 is your final matrix, which gives you the transitive closure. Just do this now. You'll be doing? Will you do it?
Yes. Yes.
Yes. Floyd, when you've done Floyd's only, this is nowhere tough problem. It's very easy only. Yes. And I want reply from everyone. I will ask here the matrix. Whomever I'll ask, they will answer for me today. Don't, those who have sent, those who have done, you just send me the snapshot. And after, I'll give you 10 minutes. After 10 minutes, I'll pick anyone and I'll ask them to read out the final matrix. Don't Google and find out or take textbook and tell. You should solve it and tell me. As soon as you tell me the answer, immediately you should send back to my number. Let me see how sincere you people are. I guess there is no problem in doing this. Is there anybody who have not understood? Anybody? So, or else you want me to do it and you want me to give any exercise to solve. Is that fine? I'll do this and give you one exercise to complete. That's better, I guess, because the class 10th yesterday was only 46, 47 from past 2 days, and I know many have not done this. These are the problems which will fetch you good marks, and easily you can get the marks. And if you're missing out these things, and if you are expecting good results, where will you get from? Okay, let's do the second one by considering the second row and second column. Those who know it, they can continue. This is only for those who don't know. Okay, I'm repeating this for those who don't know, or those who were absent for past 2 days. Okay. Yes, we will consider. For all those who want to know how we will do this, they can follow here. Okay. Yeah. So we should write down the second row elements and row element and column elements as it is. Now we will generate values for the other row and column. Now, how do we get this? Like this. 0, 1 is 0. 0 into 1 is 0. And this is already 0 we have. So we'll retain this one. To generate this, we have to take it in this way. So 1, 0. Again 0. Here, see here. 1, 1 and 0. So what should be the entry here for me? Now, what is the entry over here? Here.
1.
This is the direct
0.
path and this. Who is that? Who said 0? You have an alternate path. See here you have 1, 1. So you take it like this. This is 0. And here you have 1, 1. So 1 into 1 is 1. 1 is greater or 0 is greater, or 0 is non-existence of path. 1 is existence of path. You have found a path. You should note down that and highlight that, saying that we have found one new path. Okay. Now, to generate this value, we'll take like this. So 0 or 0, 0, or both are zeros only. As I said, for this row, it will be zeros only because we have all zeros here. Next, how do we get this? Like this, we'll do. Already 1, we'll retain. Here, already 1, we'll retain. And now, here, 1 into 1 is 1. Here we have 0. So we can just highlight this. So we have got 2 new entries, isn't it? With R2, we have got 2 new entries. Now, we will move on to R3. Okay. So we will consider the third row. Okay, third row, third column and third row. We'll write down them as it is. So we'll write down 0, 0, 0, 1, 0, 0, 0. Okay. Now we'll generate new values. So to get this, we have to take it in this way. So 0 into 0, 0. So it is 0 only. Here. To get this value, we will have to take it like this. Already 1 will retain. If it is already 1, we'll retain it as it is. Okay. So here again, if we will take this way, 0 only. Now here again, 0 only. Here already 1 is there. Here. Here like this, already 1 is there. Already 1 is there. Now here. All these are already 1s. Okay. So we don't have any. Did you get any new entry over here? No new entries, isn't it? It's same as your R3. So by placing C, you cannot, it's very obvious. See, using C, you cannot reach any other node means using the third vertex, you cannot have any difference in the matrix, right? Now, we'll consider R4 and we will check. Okay, so fourth row, fourth column and fourth row. We are taking this. Let's start now. Let's note down the values 1, 1, 0, 1 and here all ones 1, 2, 3. Now, see, I've received replies also already for this. Okay, good. Now, here, see here, if we take it like this, 0, but 1 into 1 is 1. So, we have a path. Here again, 1 into 1, already path is there, we'll retain. Here, like this, if we will take, so 1 into 1 is 1, 0 is there, so we can make it 1. Second one, we'll consider second like this. 0, here 1s, so 1. Here 0, here we can get a path 1, 1, so 1. Here if you take again 1, 1, 0, so we can have a path. And here if you take, this will be zeros only, isn't it? Because you have 0 here, if you multiply 1 with 0, it will be 0 only. So all 0. And this is your final transitive closure. Okay. So whatever values you got here, you just highlight them. So we got this new value and this as a new value, isn't it, from this table. And we got these 3. 1, 2, 3. Okay, new entries. This is your transitive closure.